Welcome to the next tutorial class. So, we will do today some numerical problems on waveguide resonator. We have already completed two problems and now here is the third problem. So, third problem is that an air filled cubical cavity operates at frequency of 2 gigahertz when excited at the TE101 mode. Determine the dimensions of the cavity. So, this is a cubical cavity and it has means resonant frequency of 2 gigahertz that is excited in TE101 mode. So, to to calculate the resonance frequency, we know that formula is Fr is equal to U by 2 a square root of m by a whole square plus n by b whole square plus p by c whole square. So, this is the formula to compute the resonant frequency of rectangular cavity. In this case, we have to calculate the means it is given resonant frequency for TE101 mode. TE101 means m is equal to 1, n equal to 0, p equal to 1. For this case, Fr it will be, and this is air filled. Air filled means U equal to C, that means 3 into 10 to the power 8 meter per second. Fr equal to, it will be U by 2 and this will be a square root of m is 1, p is 1. So, 1 by a whole square plus 1 by c whole square. So, this because here means this is a cubical cavity, that means A equal to B equal to C. So, if A is equal to C, in this case it can be written as means Fr equal to, so it will be 1 by A square plus 1 by C square. So, it will be 2 by A square, means U by 2 root 2 by A, that means U by root 2 A. From here means A is unknown, that means A equal to B equal to C and U is known, Fr is known. So, here A will be can be written as U divided with root 2 into Fr. So, A will be U divided with root 2 into Fr, that means A will be 3 into 10 to the power 8 divided with root 2 into Fr given is 2 gigahertz, Fr is given 2 gigahertz, that means 2 into 10 to the power 9. So, this will come 10.61 centimeter. So, this is A, that means equal to B equal to C. So, this is the dimensions of the means rectangular this cubical waveguide cavity, cubical cavity. So, this problem is complete. Determine the dimensions of the cavity. Next problem is an air filled cubical cavity of size 10 centimeter, means cubical cavity of size 10 centimeter, that means A equal to B equal to C equal to 10 centimeter, has electric vector electric is 200 sin 30 pi x sin 30 pi by cos 6 into 10 to the power 9 t Az volt per meter. So, here Az is given, that means here only vector E equal to Az component is there. Az component is there, that means only electric field is in the means only electric field is present in the z direction, that means no magnetic field in the z direction, that means this is for the Tm to z mode. So, this is for the Tm to z mode, and for this case we have to find out the vector magnetic field. So, vector magnetic field will be, so we have to use, we know from the Maxwell equation we know del cross del cross E equal to minus of j omega mu into h. So, we know this from the Maxwell equation. This can be written as, so h can be written as minus of 1 by j omega mu, because this is the air filled cavity. So, mu equal to mu naught del cross E, vector h equal to minus of 1 by j omega mu into del cross vector E. For this case, this is also vector, this is also vector. So, first we have to find out del cross E. So, to find out the del cross E, so we know, means we have to use this A x A by A z, del value we know, del y del x, del y del y, del y del z, and E x E by E z, and here in the question only E z is there, that means E x equal to 0, E y equal to 0, and E z will be E z. So, that is a function of x and y. So, E z is a function of x and y. So, this will be del cross E, and minus of 1 by j omega mu, that means it will be, so vector equal to j divided with omega mu. This can be simplified as, we can simplify this. So, this will be equal to j divided with omega mu, x will be common, x will be common. So, del of del y E z, so it will be del of del y E z minus 0 plus A by, so this will be 0 minus del of E z by del x, del of E z minus del x plus A z and 0 minus 0. So, A z component will be 0. This will be equal to, and we can calculate j by omega mu. So, j by omega mu, and omega we know. So, this will be j divided with omega mu. So, this will be 0. So, only A x del of E z by del y minus A by, these all are the vector, A by del of E z y del x. So, this is the h vector h, del E z by del y, del E z by del x. So, this we can calculate. So, this value will be, and this, and j by omega mu, j by omega mu will be j, and in the question omega is given, cos omega t. So, omega value will be 6 into 10 to the power 9, omega will be 6 into 10 to the power 9. So, 6 into 10 to the power 9, and mu will be equal to mu naught, that will be 4 pi into 10 to the power minus 7. So, this will be the value for the j divided with omega mu, and value for this will be j 10 to the power minus 2 divided with 24 pi. After this, means h can be written as, h will be j 10 to the power minus 2 divided with 24 pi inside the bracket and del E z by del y. So, del E z by del y will be, and 200 is the amplitude of this electric field. So, 200 will come outside because this is common in both the cases, and so we can take that common. So, 200 will come outside and then del E z by del y, that means 30 pi sine of 30 pi x and sine will be cos in the second case, because you see it is del upon del y cos of 30 pi by this one into a x. We are taking only the means complex part, not taking the instantaneous part. We can add later 30 pi and del upon del x. So, that means 30 pi sine will be cos of 30 pi x and second term will be sine of 30 pi by. So, into a y. Further, this can be simplified as means we will take the 30 pi common in both the cases and it will cancel out from the 24 pi and final expression will come j into 2.5 a sine of 30 pi x cos of 30 pi by into a x minus cos of 30 pi x into sine of 30 pi by into a by. So, this is the H field component, that is the complex part, and for the instantaneous part we can calculate like this, because we are taking the maximum value. So, for the instantaneous part we can use like this, H equal to real part of H e to the power j omega t. So, h to the power j omega t can be written as cos omega t plus j sin omega t, and this will be means we have to take only the real part. So, here it is outside is j. So, this expression will come 2.5 minus of sine 30 pi x. So, cos e to the power j omega t have to write cos omega t plus j sin omega t, and after this have to substitute this term, and then after multiplication this will come 2.5 minus of sine 30 pi x into cos of 30 pi by. So, this is only the real part into a x plus cos of 30 pi x into sine of 30 pi by a by, and this is the into sine of 6 into 10 to the power 90. So, this is the ampere per meter. So, this is the instantaneous magnetic field component, and here omega will be that 6 into 10 to the power 9. So, from this we can go to the week 9 numerical problems. Here is the first problem. For the probe feed rectangular waveguide shown in below figure. So, here you can see this is the rectangular waveguide that is fed with the probe in the middle. Determine the amplitude of the forward and backward travelling TE10 mode. So, this is in the feed in the middle of the waveguide, and both side of the waveguide are open in the plus z and in the minus z. Both side of the waveguides is open and it is travelling, means it is fed in the TE10 mode, and the input resistance seen by the probe. So, determine the amplitude of the forward and backward travelling TE10 mode and the input resistance seen by the probe, and because we are feeding from the probe from the outside. So, in the middle of the waveguide we are making a small hole, and you can see this part is the outer coaxial cable and this inner part is the probe that is touching the means other side of the broad wall. So, it is inserting from z is equal to 0 and it is going up to z is equal to b. Assume the TE10 mode is the only propagating mode in the cavity. That means, this is the only this TE10 is the dominant mode and only this mode is propagating. So, first we have to find out the amplitude of the forward and backward travelling TE10 mode. So, here is the waveguide, means x, y, and in this it is A, and in the bidirection it is B, and in the middle one probe is there. So, this is the probe and it is feeding by making one hole, and this is the outer coax, this is the ground PEC, and here it is inner probe. So, that is feeding from this, and current flowing on this is I naught. Current is I naught on the probe surface, and this side is B. So, if the current probe is assumed to be means to have an infinitesimal diameter, means probe diameter means radius of the probe is very small, and only means current on the probe is means existing only in the z direction. For only z directed current we can write surface current on the probe surface as J, means for a very small radius of the probe we can write J in terms of x, y, z equal to I naught. I naught is the amplitude of the current, del of x minus a by 2 del of z into a y, like this we can write. So, this is in the bidirection, this is in the bidirection, and here means feed is at the x is equal to a by 2, that is in the middle of the waveguide, and it is into del z. And for the TE10 means for TE10 means normalized electric and magnetic field can be for the TE10 modal fields can be written as for the TE10 means normalized electric field and magnetic field can be written as E1 equal to A by sine of pi x y a. So, this is the transverse component of the electric field, and H1 equal to minus of a x y z1 sine of pi x by a. So, this is the transverse component of the means magnetic field, and it means electric field is in the bidirection and magnetic field has x component. So, this is the bi component of the electric field and this is the x component of the electric field. So, H1 is equal to minus of a x y z1 sin pi x by a, where z1 is the TE10 wave impedance. So, T10 wave impedance for T10 mode, that will be k naught eta naught divided with beta 1. So, this is the wave impedance for the T10 is the T10 wave impedance. Normalized means normalization constant of the nth mode is. So, we can calculate the normalization constants. The normalization constant of means we are writing for the nth mode, then we will come to the T10 mode of the nth mode of the nth mode is. So, we know that normalization constant, that is denoted as Pn, that is equal to 2 upon S naught En vector En cross of Hn into this dot product with Az into ds. And for the T10 mode, for T10 mode, for T10 mode, this will be P1 equal to 2 into, so n will be replaced with 1. So, E1 cross with H1 Az ds. So, this will be for the means for the T10 mode, and after this we can substitute the value of E1 and H1. So, after substituting the value of E1 and H1, this will be 2 upon S naught. E1 is A by sin of pi x by A cross with minus of x upon z1 sin of pi x upon A. So, this is the H1, right. So, this is H1 dot with Az ds. So, this is the E1 cross H1, and this will we will get means A by cross minus A by cross Ax. So, this will come minus Az and minus minus plus. So, it will be Az and Az dot with Az, it will be 1. So, equal to 2 means S naught. So, that is on the means probe surface. So, this will be 2 and Z1 means taking outside Z1, this will come x is equal to 0 to A by equal to 0 to B. So, it is on the means inside the waveguide. So, sin square pi x by A into dx dy. So, this will come 2 by Z1. So, sin square pi x by A. So, this will be 1 minus cos 2 pi x by A. So, by 2. So, this will be 2 upon Z1 x is equal to 0 to A by equal to 0 to B 1 minus cos of 2 pi x by A divided with 2 into dx into dy. So, from this we will get means on the x integration we will get A by 2 and on y we will get b. So, and 2 will cancel out, that means A b by Z1. So this will be 2 upon Z1 into, for the dx case we will get a by 2 into, on the b integration we will get b. So 2 will cancel and P1 is a b upon Z1. So this is the value, that normalization constant P1. So amplitude, we can calculate the amplitude, means first for the positive travelling wave we can calculate the amplitude. So amplitude of the positive travelling wave is given by amplitude of the positive travelling wave so of the positive travelling wave, that is given by, means that is denoted as a n plus, and that is written as minus of 1 by P1 Pn, because this is for the nth mode. So Pn, and this is the volumetric integral En minus Az into Ezn. So this is the z component of the electric field, and first one is the transverse component we have separated. So this into j e to the power j beta n z into dV. So j cap, that surface current, and e to the power j beta n z into dV. So for the T10 mode, for T10 it can be written as a n plus equal to minus 1 by P1 V into E1 minus Az Ez1. So Ez1, here it is no z component, so that will be 0. J e to the power j beta 1 into dV. This will come, and now we can substitute all the value. So this will be minus of 1 by P1 V, and E1 is a by sine of pi x by a minus Az, there is no z component, this will be 0 into, now we can substitute the value of j, that j value we have written in the first. So that is I naught del of x minus a by 2 del into del z into a by. So this has a by and one more remaining is this one, e to the power j beta 1 z into dV. So dV will be there. So dV will be dx dy dz. This can be written as, again this can be written as minus of 1 by P1 integration on. So this is the volumetric integral, that will be sine of, and now we can see this a by dot product with a by, this is, that is outside. So that will be 1, and total integral will be sine pi x by a sine of pi x by a into e to the power j beta 1 z I naught del of x minus a by 2 into del z, and this will be dx dy dz. dx, dy and dz. So, after this will come, here it is del of x minus a. So, integration for this will be means, because this will be, we have to substitute x is equal to a by 2 in the sin pi x by a. So, if that will be means it is like this. So, at x is equal to a by 2, so sin of pi by a into a by 2. So, at x is equal to a by 2, this value will be pi by 2 and value for this will be 1. So, integral value will be 1, and for del z into the power j beta 1 z, for this case z is equal to 0, have to substitute in e to the power j beta 1 into z, this will be 1 and again integral will be 1. But for del y, this is from y is equal to 0 to b and that will be b. So, total value will be minus of 1 by p 1 into 1 for sin pi x by a into del of x minus a by 2, and for the del y it will be b, and for the del z means at z is equal to 0, this will be 1. So, total value of the integral will be minus of b upon b I naught, 1 I naught is remaining. So, this is minus of b I naught upon p 1, and p 1 value we have, that is a b upon z 1, that we can substitute. So, that will be minus of b I naught a b upon this z 1. So, this b will cancel and this value of for this will be value for this means a 1 plus, that is the amplitude of the positive travelling wave for the TE 10 mode. So, this will be minus of z 1 I naught upon a. So, this is the means a 1 plus amplitude of the positive travelling wave. So, this is for the positive travelling wave. Similar to this, we can calculate the amplitude of the negative travelling wave. So, that we will calculate in the next class. Thank you.